Today I have a return visit from Lance McCarthy. Lance is an old friend of mine, and he's a senior manager and technical support at Progress Software for the Americas. You might know Progress Software for Telerik and Kendo controls or for Fiddler. He's also a Microsoft MVP since 2013. He's a .NET MVP and a Windows Dev MVP. He's also one of the smartest people I've ever met. Lance, how are you?
I'm doing well. Thank you for having me back, Jesse.
I'm really excited to have you here. The last time you were here, we started talking about MCP, and we realized, or I think we sort of came to the conclusion that we wanted to go deeper and that we'd ask you to come back and really dive in a concrete way, and that's what I'm hoping we'll do today.
Yep. MCP is one of those things that seems like a black box magic thing that your GitHub Copilot chat will use. Today, I'll help demystify that with some hard-coded tools, right? It'll just do some math and then give that back to Copilot. And you're like, oh, that's what MCP does. And I think that really will help a fundamental understanding on using different tools and how to even set up an MCP server, which I'll show today too.
Well, you already told me something that I didn't know. I thought that you only used this when you were building your own application that had agents in it. You're saying I can use that with an existing agentic solution and sort of extend what already exists by using MCP. Do I have that right?
Yep, it's exactly right. To keep things simple, let's just talk in the context of GitHub Copilot today, because
Okay.
that's
Yep.
in the but it works in the Copilot's CLI. It works across multiple different AI solutions because MCP is a standard. Just like what JSON did and XML did for the internet, MCP is that interconnectivity that multiple agents can use multiple MCP services.
Hence the protocol in MCP.
Yep, model context protocol.
Gotcha. Okay, I think all this will become a lot more real for me when you show me some code.
Yep. So
Show me the
it's
code.
best to just dig right in, right? So
Yeah.
let me start sharing and you can see my desktop here.
Yes, I can.
All right, good. So the first thing I will show is how you would actually set up an MCP server.
Okay,
What you
it's a little small. Can we maximize that?
Okay, so here we have the file called mcp.json. Most IDEs and editors use this file name. Visual Studio 2026 will use a .mcp.json file. VS Code uses an mcp.json file. Whatever IDE that you have, it has docs that shows you, oh, this is where you list your MCP servers. And many of them have a UI that you can add them into, but the most common way to do it is with the MCP JSON file, and you actually put in your server like this.
I'm going to ask you a lot of questions as you go, if that's okay.
Yep.
You're building this in VS Code, so you called it MCP.json. But if you want to take this and run it against Visual Studio, will you need to change the name, or you can leave it the way it is?
So this is just a settings file. It's like a regular config, right? So let me
Okay.
save
Yep.
it and show you how to actually get here.
Okay.
So I'm not actually building it in VS Code. I'm showing it being used in VS Code, but we're going to build it in Visual Studio.
Okay.
But essentially, let's say you are here, you're in your VS Code or Visual Studio, you go to your MCP server settings. So in the case of VS Code, I just do MCP open user configuration. And that will automatically go to the file path of where your MCP JSON is. In my case, and in the global file for all VS Code is in app data code user MCP JSON. For Visual Studio, it's in the home folder and in a .mcp JSON file too. But whatever IDE settings will bring you there to do a straight shot. And all of them look like this. So this is the standard, right? So we have a servers list inside that JSON configuration file. There are other options, inputs, and a few other things that are outside the scope of today's call, but this is basically a settings file that you do with any other kind of app.
Great.
And you name your tool. You tell it what kind of type it is, and you tell it the command to start it, and then you give that command some arguments. There are 3 different ways to set up your MCP server, depending on how you built it. So you can see I have a couple other options here. Let me uncomment them. This is the same application I'm going to show you shortly, but 3 different ways that I can actually add it as run it as an MCP server and add it to this MCP file. VS Code, or more specifically, GitHub Copilot, looks at this file, says, okay, I see you have a server named MCP Playground. It's a standard IO app. And in order for me to run it, I need to call DNX, which stands for .NET Tool, by the way. So that's a .NET Tool install command. And it's saying, hey, the name of the NuGet package is this. And this is just some arguments to install it without a prompt. Well, what if you don't use NuGet, or like you're in an environment that, Node works better? You can compile the app as a Node package. And this is the same application, by the way. All 3 of these are the same MCP server application, just running 3 different ways. So it's still a standard IO, but this time GitHub Copilot will use the Node startup script. NPX is very familiar if you use Node. And the name of the package, I published it to npm.org as this package name. And I always use the latest version. Finally, I will show you this later. You can pack it up as a Docker image. If you're running Docker desktop, or if you have some sort of environment that Docker is a better solution for you, instead of installing .NET or Node, you even don't have a Node runtime, you can do a Docker image. So same thing here, standard IO app, and the command to start the MCP server is Docker run interactive, and this is the name of the image that the app was compiled into. And the cool thing is, because .NET has a built-in native way to create Docker images, I could use that and when I compile the project, or I can use a Docker file. I chose a Docker file. I'll show you that later. For the purposes of today's demo, I'm just going to use the first one because I use .NET 10. So the .NET Tool scenario is more applicable for .NET 10 and later because of the way .NET Tool install works and where these packages come from. Most common scenario most people use is the Node runtime one. And that's why if you're still using .NET 8 or .NET 9, it's better for you there. So let's take a quick look at what this actually does.
Is this code going to be available somewhere?
Is it what?
Will it be available? Do you have a GitHub repository or something that people can go look at this code?
Yep, all of this code is on GitHub, and we'll visit there next before I actually even open it in Visual Studio.
Great. So we'll put the location on the show notes.
It looks like I actually unpublished it. So let's let's switch to the Node one. That's what I wanted to check first. All right, and I'm going to change it. A different name. We'll call it. Give this server name. MCP Playground Node. So once I save this, VS Code knows how to use it. So if I come over here and I open a GitHub Copilot window, a chat window, if you come to the settings, this little configure tools button, it'll show a pop-up. And in that pop-up, it shows all of the MCP servers that you have listed and which ones are enabled and aren't enabled. You can see I have a bunch of them here, right? I have one from work, the Kendo. It's a specialist in Kendo Angular. I have one here that's a specialist in Telerik Blazor. And you can easily enable and disable them just by checking and unchecking. This helps startup time. So I'm going to enable my MCP server here. Inside the MCP server, update it. It should spin it up. And we can see my 3 tools. What it just did in the background was run that command that I showed you in the MCP JSON file. It ran npx, ran the package name. If it wasn't already installed locally, it would pull it from npm org. And inside my MCP server, I have 3 different tools. A tool called Get Fibonacci, a tool Get Latitude and Longitude Information, and Get Lucas. Lucas is just an alternate Fibonacci. Now, how do you actually use it? Let's go and start a chat. I'll start a fresh chat session just to make sure. Here we are. And I have auto set for the agent. So a lot of people ask questions on like, which one should I select? It really depends on the task. Opus 4.6 I use for like security investigations, deep architectural discussions, but it's more expensive, right? It costs 300% higher tokens on your account than Sonnet or GPT does. So generally speaking, if you leave auto enabled, it will make a decision on make a quick chat back and forth that doesn't require some deep planning and actions. And then when it does, it will step back in the conversation, say, okay, let's create a plan, and it will show you creating a plan. Here I'm going to say, and the way you reference a tool is by its name too. So I have MCP Playground Node. See the hash? I think you can still use the @ symbol, but I haven't seen it recently. I think it's just Get Fibonacci, right? So that went by really quick, but it was starting the it started the MCP server itself. And because it's the first time I'm using it, GitHub Copilot will ask for permissions to do certain things. It won't go off on a tangent and do stuff that you don't know. Particularly with MCP servers can contain malicious code like it says here. It could be used to extract secrets from your environment, for example. Now here, I know this MCP server, I trust it, so I'm going to allow it in this session. So right now it's using my MCP server and invoked a tool called Get Fibonacci. Notice how my spelling is not exactly the same as the tool's metadata. The GitHub Copilot agent understands the context of what you're asking, and a lot of times you don't even need to use the hash symbol if you're already in a conversation. It'll know to the context on what tool you're trying to use. But here we go. It returned the Fibonacci sequence. Yes, I could do that with the LLM because Fibonacci is trained, right? Like the Fibonacci sequence is very old. It's going to be in the training data, but I use this as an example of a specialized tool that we can see the code that was used to create the answer. So are we caught up to this point? Do you have any questions so far?
No, I don't have any questions. That was very clear and very concrete. So thank you. There's some setup there. I don't know how much of that is you and how much of that is standardized, and maybe you could just say where I find that out. Where do I, like when you go back to that configuration file, is there documentation somewhere that says, oh, here's what you put in these different entries?
Yep. So GitHub Copilot has a lot of documentation and it's like 9 or 10 different articles on MCP servers too. The easiest way that I find is just to use the configure tools button, and you can add or remove tools here. But Control P, MCP.
Mm-hmm.
Right. So this really gives you the root of all the stuff that you typically would use, right? You can open the configuration file, or you can add them manually. You can show install to a different way. I personally like the JSON one, right? So now that we've had this chat, let me leave. For example, in the Telerik docs, we have all of those servers that you saw in my list, right? My Kendo
Yes.
Assistant, right? These are all those servers that are there. And in our documentation, we give you this. We say, hey, add this to your MCP configuration file. And
Gotcha.
you as a user would know which one you want to add it to.
Okay, that's great. So that's using a server. Are we going to talk about creating servers, or is that a much bigger job?
No, it can be. But to get started, I think we should actually see the code that created my server.
Great.
So let me open Visual Studio here now. I'll zoom in. So to start, this is, let me open the project file and show you what it actually is. This is just a .NET 10 app. Right? It's a C# .NET 10 project. It's just your typical thing. What matters is what packages you install. So my version might be a little outdated here by the time someone watches this, but this is basically what you would install. And then you get access to the different attributes that you would add on a tool. So let me show you the program file.
And these are NuGet packages.
Yep, they're your standard, like there's no mystery here. This is a regular .NET 10 class library style application, right? And it uses dependency injection like any other modern .NET web application. So we're coming in here and we're adding MCP server.
Great.
And here's the standard I/O. So that's how the actual server works and communicates with the end application. And that's what we saw in the MCP JSON file. And on top of that, I'm defining the tools that I want to expose through my server. There are two tools that you see here. We talked about the Fibonacci one, and I have that underneath my numeric patterns tool. Let me collapse these and show you the main takeaway, right? Here's where we lift the veil. Like, how did it figure out the thing that it gave me? Because I named the tool, right? First, you create a class. It just got to be internal or public. And then you give it a description and this attribute to the methods inside of the class. So each tool is a public method that returns something. In this case, I'm just saying, okay, the name of the tool is called getFibonacci. This is the description of the tool itself, and it'll also have it inside of the parameters. So I have a parameter called length, how long of a sequence do we want for the Fibonacci, and then a description of that parameter. And that's basically it, right? So inside here, you can do whatever you want, and then you return it. So what happens is GitHub Copilot invokes this tool when it is either @mentioned or it's inside of some plan that's going to invoke the tool.
Great.
Same thing down here, get Lucas. Same thing, right? It's saying how long do I want it? This is the description of the tool. And that's where this comes in. So I'm saying, okay, this is an MCP server app. We use standard IO and it exposed this this tool, all of the tools in this class because I have two tools in there.
Great.
Now over on the dynamic tools, the get lat long info, this one's a little more dynamic. Why I call the class dynamic tool, right? So it is expecting and actually requiring input for it to work. In order for this tool to work, we need coordinates for the place to get information about it. The whole point of the tool is to figure out that information where it is. And I make an HTTP client call out to some external service. And the reason why I made this demo like this is because a lot of MCP servers are actually proxies to a larger service. So like the LLM example I gave earlier, an MCP server is actually a different LLM that specializes in something else. So this is how you can make a remote request inside your tool to invoke something bigger, more expensive, more elaborate, more GPU power, and return back that information. So it's just the standard HTTP client request. All the other code in here is just parsing the response and returning that back.
So it feels like calling an API.
It's exactly what it is. It's an API for an AI, and many of the patterns are the same, right? The only difference is you're using this tooling here, and the MCP tooling, the the MCP SDK comes with great documentation on how you can set up your inputs, how you can do your outputs, progress. You can report progress as it's working. So, for example, in the Telerik MCP servers, we always report progress on what stage it's doing, what it's working on at that time, because some tasks can take up to 2 minutes building a very complicated UI. We also have RAOs, which means that, so it is basically like a conductor at a concert. Imagine you have an orchestra. The orchestra are all sub agents that are specialized in their instrument and what they do. And you have the conductor. The conductor is not specifically an expert in anything. Its responsibility is to coordinate responses and information between each person of that orchestra. And the actual word orchestration is in RAO. It is
What does the
retrieval.
RAO stand for?
I think it's retrieval agent orchestration.
Okay.
Yeah, I could be slightly wrong. Yeah, retrieval agent orchestration. Yeah. So basically it's saying, okay, these agents retrieve different information, and its job, the top agent, its job is to organize all of that to then return to GitHub Copilot.
Gotcha.
Yeah. So now, like, okay, you've got some tools that you put together. How do you actually make it available as an MCP server? I'll start with the Docker file since I already have it here in Visual Studio. No mystery here. It's just creating a Docker image with the DLL of my server. This is exactly the same thing as if this was an ASP.NET Core application, a web application.
Yep.
Yep. Now for the others, I build them in GitHub Actions. So let's go over to the GitHub repository where this project is. So I'll share the link with you, or just it's Lance McCarthy, MCP servers. And in the README, I give you a little bit more information like, oh, if you're using Visual Studio, this is where your MCP file is, MCP JSON file. If you're using VS Code, this is where it is. Claude Code has its own location too. It's very similar to where VS Code is. It's in a Claude folder. And I have some GitHub action statuses, right? So this action publishes the package to NuGet. This one publishes it to npm, and this one publishes it to Docker Hub. And in the options, they say, okay, if you want to use the .NET Tool one, add this to your MCP servers list, and same with the rest. Then I just explain what tools are in there. That's a little outdated. I'll have to update it with that long one, but that's the point. Very simple, straightforward docs. So let's start with publishing to npm. This is the most common one. When I push my code to GitHub and I have a trigger on the releases branch, I could have it trigger manually. If I want to push a release to npm manually, I just can go and do a manual trigger. But typically, I like to do it on a releases branch. So if I push a new branch called releases v1.0, this action will run. And the job npm publish, it just does .NET publish. Okay? It's your regular publish command. There's no secrets here. It's just self-contained. And what's the last flag? Publish single file and to an output folder. That output folder is where the DLL is now, right? So the app compiled, it's now a DLL, and it is an MCP server. Next thing I do here is I create a package JSON file. I could have it in the code already, right? That whichever way you prefer. I just dynamically create one real quick in here because you need a package JSON to publish an npm package. Inside, where is it? Inside the npm package is a bin. This is how you actually get your .NET application into a Node package. Right? You're like, wait, these are two different technologies. How is this working? It's just an exe. I'm telling it where it is. It's inside the bin, and it will run it because when it compiles, when this .NET publish command completes, it creates the exe file, and that's inside the bin folder. And then finally, I just publish it to npm.org, npmjs.org. No super secret stuff here. It's just very straightforward. We publish the package with the exe of the server in it. Now here's the NuGet action. Similar, but because NuGet is very compatible with .NET already, we have a .NET pack command. And all I have to do is call the .NET pack. I set some versions on it, right? But I just say, okay, pack it, build it in release mode, and output to this folder. The next command is .NET push, .NET NuGet push, and it pushes it up to NuGet.org. Finally, for the Docker image, it runs the Docker file. So down here on the bottom, all this stuff up here is just me dealing with the tag for the image. Like I wanted to have the latest tag or the version for the tag, and I sign in through Docker Hub. That's all this stuff ahead of time. It really only requires one single action, and this is the Docker push publish command. And I basically say, hey, I say, hey, here's the context, which basically says the folder that the Docker file is in. Say, hey, look in here, look in this folder. This action will find the Docker file, run it, and then that's how we get the image with the exe in it. Or in this case, the DLL and not an exe. But now, when those run, we have these things available, right? My MCP server is now available on one of the 3 distribution systems, and you can use whichever one you want.
Yes, that's very cool. If you were going to draw, now that we've seen the code, conceptually, if you were going to draw this, what we have is an MCP server, and connected to the MCP server are tools. And then on the other side of the MCP server is your agent.
In front of it is the MC. This is the beautiful thing about MCP is it's compatible with a ton of stuff. If you go into Copilot Studio, like let's say you have a Copilot Studio license, you can write a Copilot agent that works inside of Copilot for Windows and inside your organization as an agent. It can be GitHub Copilot, right? So if we come here, whatever your top thing is, and that's why I was trying to make a distinction on what you define as an agent, because it can be the top agent, like Copilot Chat. It can be another MCP server. It can be a tool inside of GitHub Copilot. Microsoft 365 Copilot. But it's cross-compatible because of the MCP JSON ability to do all of this. You could use it anywhere that supports MCP.
Gotcha. That's great, and not as mysterious as it seemed at first. Seems
exactly right. So that's what I wanted to really bring home today with. Oh, I didn't install it on this computer yet. The Copilot CLI is another tool that just came out. So people are like, MCP is dead. CLI, long live CLI. I want to touch on this very quickly, right? Let me actually install it while we're waiting. Some people don't use IDEs all the time, right? Imagine you are an infrastructure guy, you're a network engineer guy at your company, and you don't use Visual Studio or VS Code or Claude Code, right? You might actually use maybe like ChatGPT in the browser or something like that. And it's kind of hard to make it the ChatGPT in the browser to work with whatever systems that you have. Like you want that tooling to have more context of what's going on. And you see these developers using GitHub Copilot and Visual Studio, like that's awesome. I want that for my project and all of my configuration for my networking infrastructure. And that's where GitHub Copilot CLI is. It's basically everything that you see that developers get to use in their IDEs in a simple CLI. So you can give it the context of whatever you want, and it will basically just works. And it looks like I'll be able to show you that quickly. It's almost done installing. But while that's happening, let me show you here. So they have a nice animated GIF, and this just Google Copilot CLI, like I did a second ago. It'll get you here. You can install this everywhere. It works in Mac OS, it works in Linux, everywhere, right? Anywhere they have homebrew, winget, npm, and you can actually, use like a custom script, but those work perfectly fine. And you get something that looks like this. Right now, this is open in Bash on Mac OS. Works there just fine. I like it in PowerShell or Windows Terminal to be more specific. Let's see how it's doing. Almost done installing. And what you get out of it is a conversation that has MCP servers, it has tools, it has everything that you can imagine. It works so good that you might choose it over GitHub Copilot inside the IDE. But you don't necessarily have to. Inside the IDE, you have GitHub Copilot Chat, and it understands that you have a GitHub CLI session open somewhere else. So you can just open it like a terminal. You go to the directory that you want to, use your LLMs in, and then you just type in the Copilot command. So that's what I'll try here. So let's go to folder. Downloads is wrong. Oh, let's try downloads. Right, so let's say my project is in downloads, and I wanted to do something, right? So I'm just going to open Copilot here, Copilot CLI, if I can spell. Oh, I think it went and updated PowerShell first, and then it didn't finish installing CLI. That's how quick it was. I just installed GitHub Copilot CLI. Clear. Now I'm going to start a session. This is the out-of-the-box experience for every time you launch the CLI. The first thing it's going to do is say, hey, do I have permissions to look at these files? Like, do you trust the files in the directory that you just opened my CLI in? I'm only going to say yes once because I don't want it to have access to my entire user directory right now, but I'll just say yes once. Everything's all set. Now I can use the CLI, but this isn't just like your normal command line tool. It is very good at like a GUI. You have like a terminal GUI, tons of different commands and features are built right inside of the CLI. There's kind of gives you a hand here. Shift and tab changes the mode from plan, autopilot, and regular. So plan, it won't take action yet. So let's go back to the network engineer scenario. Like I want to change these configurations to set up a site-to-site VPN between this IP address and this IP address. It would do it first without actually changing any files and then ask you at the end if you wanted to. Autopilot, it will do both at the same time. So you don't have to sit there and babysit it and approve every single thing. And regular is, let's see the shortcuts, right? I don't have a Git repo open in the folder, but if I did open the CLI in a Git folder, it has full understanding of what's in the Git history there. We have shortcuts that work really cool. Right, so I just hit question mark or slash to see all the commands. And again, back to MCP, we could set up MCPs. The command is MCP show, add, edit, delete. So let's take a look at show. Because this MCP file is different for the CLI. Notice how that is not just a MCP.json like it is for VS Code. And we can open this JSON file and add one.
There's a lot of excitement about the CLI, but personally, being able to do all of this inside the IDE and not have to leave the IDE in order to work with MCP has a great deal of appeal because I spent most of my life inside the IDE.
You can do both. So let's try this, right? So I was working on my Azure extension earlier. I'm trying to solve a problem here, right? So I could open it here. So Copilot And if I'm a big terminal guy, I personally prefer the GitHub Copilot chat window
Hmm.
um, when I'm inside the IDE. But if you prefer a terminal window, you can now do it in a terminal window. There's a huge population of developers that would rather just be in terminal. So you can do it here too. And this has
Very
full
nice.
understanding and context of everything in the project, right? So let's try one simple one. Update the README to include information about the new multi-line secret feature I just added this morning. Oh, I'm not signed in. Another thing too is you give it certain permissions for certain things. I'm on my personal computer right now, so I'm not going to authorize some of the other organizations. So I'll just continue. I understand that I gave it some orgs you can't actually get access to, like Microsoft MVP org and some of these other ones. So I'm just going to skip that. All right. It stays the token stays a long time. Like I have noticed I've never really had to re-auth after a while because I use it almost every day anyways. All right, so we're back in VS Code, right? Let me rerun the same prompt. Let's see if it'll let me do it. There we go. Okay, it's thinking, right? It's a very, very well designed CLI tool, to be honest. Like the way that it updates the text in the window, the way it uses visual elements to keep you engaged and understanding what's going on is fantastic. Definitely one of my favorite terminal GUI kind of setups that we have. Yep. And this
Very
is
nice.
raw, right? I haven't done this yet. I just installed it for the first time. I just signed in for the first time. And so we have no pre-prep, and this is working in real time. It's looking at the entire code inside of this project folder. It's trying to understand what I just added.
When you're working on the CLI, can you give it context file like the MD files that you would with in the IDE,
Yeah. So
like
you mean
Copilot
like when you have a file
instructions.md?
open? Right. Yeah, I think I understand. Like that was one of the things I was worried about, right? For like, oh, CLI, how's it gonna know about the files I have open in the IDE? It doesn't necessarily need to, right? So when you have it open in GitHub Copilot chat, you tend to see the open file that's in the IDE already be listed in the chat window saying, hey, this is the context I'm talking about. Talk about the file that's open right now. But generally speaking, it needs to go and look at the rest of the project anyways to understand what you're trying to do. And it just
Right,
did that now.
right.
There.
What I was asking about is Copilot instructions.md
Yep.
and similar files like that give you, a whole host of context. Maybe you don't work with those.
No, that is like when I'm using the CLI, I
Hmm.
put the Copilot instructions inside of the GitHub repo, the Git repo that needs the separate instruction for context for that project.
Okay,
Um, but you can have a global one and you can have a local one, and it will load instructions for both.
great.
That is actually like a whole session on itself. Um, GitHub has very good instructions and guidance on how to set them. So while this is running in the background, so here's the doc. So all I did was search GitHub Copilot custom instructions MD. So we get some really good guidance on how to create a good custom instructions file. And there are two different kinds. There's actually three different kinds. But Copilot instructions will tell either the CLI or the chat window where base information you want it to know. You can say, hey, the files in this folder do this, right? These files over here do that. Use this styling guidance when you're writing code. You can even tell it to behave differently. You can say, uh, exclude pleasantries when answering questions. Right? Don't say, oh, that was great. That's awesome. You're smart kind of stuff. You can tell it to be like, stop being a sycophant and just get right to the point.
Right. One of the things that I do is I have a file that tells it how to create my instructions file.
Yeah.
So it has it read through the entire project and say, okay, now go create the instructions based on the styles and the
Yep.
the context of the entire project.
One tip I do tell people is use Copilot to help you write Copilot instructions,
Yep.
right? So you can say, hey, I need to write a good Copilot instructions for this repository. How should I set it up? Or give me a good scaffold. And then the GitHub Copilot agent, the one that you're working with in the chat, will look through your project, get a basic understanding of everything, and say, okay, this would be a good custom instructions file for me. And then it'll give it, put it in there. Then the next time you launch it, it doesn't have to go through all of that pre-processing stage.
Right. Well, this was fantastic. Go ahead.
Yeah, that's basically it. So right now, I just use the CLI to update the README because I added a new feature this morning, literally, but I hadn't updated the README yet. So instead of using the chat window, which I would have normally done, I just used the CLI instead. Here's the key part. I'm going to open the chat window. Check this out. You see this little session up here on the left? So here's my initial investigation 2 hours ago when I was trying to figure out the problem. The problem was multi-line secrets like RSA keys are causing it to crash when the Azure DevOps task is running on Linux. Works everywhere else, only in Linux the problem. So I did my investigation, I worked on it, I finally said, okay, let's encode it base 64. Now, these are old sessions that I had open in this chat window. This one up here is the CLI one, the one that I have open in the CLI. It's not like this is, it understands the session that you already have open. So they're not separate worlds, they're part of the same world.
Nice.
Well, I mean, I don't really need to drag that on too much more. Like that's basically it. You build a server. It can either be a proxy to a backend service that's much more powerful. It can be a built-in little piece of code that is beneficial. Skills or something else. You don't need an MCP server and tools if it's a simple skill. You can write a skills MD file that has instructions in it, and then that will do a particular one task. For example, I wrote a skill file that sets up the Telerik NuGet server for you, or fixes one that's outdated. It doesn't need an entire MCP server. But these are one of those things that like you need a scenario that makes sense for what you're doing for it to really click. But I hope those simple examples of Fibonacci sequence helped.
No, they do. They do because this was MCP can be a little intimidating at first. The way it's talked about and the enthusiasm, frankly, in and of itself can be a little intimidating. And getting it concrete like this and seeing the fairly straightforward configuration and then the server and how the server talks to the tools and then what that provides. I mean, making that very concrete was extremely helpful, and I think that people will find that very valuable. I certainly found that very valuable.
Yeah. And it helps me understand more complex tools. Like we at Progress, we have one relatively new MCP server that is in, it builds your UI. Like it will literally build everything for you. And it is kind of an RAO. It orchestrates between tool A, B, and C, MCP server A, skill C. Like it uses all these different things, it brings them together to create the thing that you want in a simple chat window. So
Gotta love it. Gotta love it.
Yeah.
Well, can't thank you enough, Lance. You are, once again, you nailed it. This was great. This was extremely helpful.
I'm glad to be here. Thank you again. I appreciate spending time with you. I always have a lot of fun nerding out.
This was great.